This is page 528, class example 2. So I kind of just tried to like organize the information that was on there already. So if you look at that page, it says like, yeah, the printing press was bought in 1999. It depreciates in value the same amount every year. So we know that tells us that we're dealing with an arithmetic sequence. Because the decrease is linear. So, and then the information that we get is that like 5 years after its purchase, so I did this kind of years since purchase, years after purchase thing. 5 years after its purchase, it was worth $311,000. And then once 2017 rolls around, which I guess is 18 years after its purchase, it only has that value, which is basically just for scrap metal or whatever. Part A is asking me to find the common difference. Depreciation per year. B is asking me to find the purchase price. So because it's asking me to find the purchase price, I probably want to set up my sequence so that this is my T1, right? Because I kind of want to like solve for T1. So here's the thing. I have two unknowns because I want to find the common difference and I want to find the purchase price. And we saw in another video, we could set up two equations and solve the system of equations. So general formula being Tn equals T1, the starting point, plus n minus 1 times d, the common difference. So because I have these two kind of like, these are my two pieces of information basically. The fact that stuff was this, the value was this in 2004, which is T6, just based on the way I'm setting up my sequence so that T1 is my 1999 starting point. So I have these two pieces of information, the $2 values, and I know that n is 6 for this first value, and I know that n is 19 for this second value. So that gives me two equations. When n equals 6, T6 but T6 is actually 311,000. Plus 6 minus 1 is 5d. So I have one equation here when n equals 19, T19 equals T1 plus 19 minus 1d, and T19 is 2900. T1 is an unknown. 19 minus 1 is 18D. So the nice thing is I have two unknowns and two equations, because my unknowns are the T1, which is going to tell me how much did that printing press originally cost, and then D, my common difference, which is going to be what was the depreciation per year. So the great thing about this is the coefficient on T1, on both of these T1s, is already just 1. What I mean by that is it's like 1 times T1, 1 times T1. So since these coefficients are already the same, we can easily use elimination. So I'm going to subtract, because I need T1 minus T1 to be 0. So I eliminate T1. I've got to do the other stuff too. 3, 1, 1. And then 5 minus 18 is negative 13D. So basically I know that negative 13D equals 308, 100. To isolate D, I can divide both sides by 13, negative 13, negative 13. D equals, because these are canceling out when I do that, D equals minus 23,700. So this would be the annual depreciation. And then remember, with systems of equations, we still want T1 though. When we did elimination, we got rid of T1 in the question, but now I use the value of D to solve for T1 using one of the other equations. So let's say I just take, let's just take the top one. 311,000 T1 plus 5 times negative 23,700. So I'm taking my value of D, and where in the original equation there's the unknown D, I plug that in here, and that means I only have one unknown, and I can solve for T1. So 311,000 times 5 T1 minus 118,500, and then I can add 118,500 on both sides, and then that's going to give me T1 by itself. So the printing press, the original price the purchase price. The purchase price would be $429,500 with this value of depreciation. All right, so page 529, class example 3. Basically, we have a pile of bricks. There's 28 bricks in the first row, and each subsequent row has 2 more bricks. So that's a constant increase, the common difference. So I know this is an arithmetic sequence. The starting point, or the first term, that's given to me. It's the 28 bricks in the first row. And then the common difference, since we're getting 2 more bricks every time, the common difference is plus 2. And in this sequence, n is going to be row number, because if n equals 1, that's T1, and that's my first row where there's 28 bricks. And then I'm going to be going up 2 every time. So just to complete the table, I will be going up 2 every time. Okay, you know how we have spoken about domain? Domain was the set of all possible inputs. So which values can get plugged into an equation. And the thing with arithmetic sequences, if you think about n being the input, so think about n as the input of a sequence's general formula. So, but the thing about an arithmetic sequence is n can only be from the set of natural numbers. N is only ever a natural number. 1, 2, 3, 4, 5, and so on, when dealing with arithmetic sequences. Because we can't have the like 1.125 term. We have to have just the first term, the second term, the third term, the fourth term, the fifth term, the sixth term. So what this question is just trying to get you to think about is that we can connect the arithmetic sequence with regular linear equations, linear functions. So connecting arithmetic sequences with quote, quote, regular linear equations / linear functions. The only difference is that the domain for an arithmetic sequence only includes natural numbers. Sometimes I call the natural numbers the counting numbers, basically 0 is not included. N doesn't get to equal 0 because T1 is the starting point of the sequence. We don't have a T0. Yeah, so we can think of natural numbers as counting numbers. So if this is the case, let's try to graph. So if this is the case, on my horizontal axis for my inputs, that's going to be my n. And on my vertical axis, that's going to be my Tn. So instead of like x, y, my input is my n value, my output is my Tn. So let me just write that here. Input is n, output is Tn. So I can pretty much graph this. I'm not gonna put a dot where n equals 0 because there's no such thing. I have to, when I'm thinking about the arithmetic sequences, n is only ever a natural number. 0 is not an input when we're dealing with arithmetic sequences because we start with T1. So in this case, when n is 1, I need Tn to be 28. So when n is 1, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. So when n equals 1, here's that slightly bolder line is n equals 0. When n equals 1, T of n is 28. When n equals 2, T of n is 30. When n equals 3, T of n is 32. So I'm going up by 2 every time. And I'll just do this until I run out of space because I will run out of space at a certain point. But the main thing is trying to show you that we can think about an arithmetic sequence as a linear equation. The thing is, though, we shouldn't connect this line because since the domain only includes natural numbers, counting numbers 1, 2, 3, 4, 5, and so on and so forth, I shouldn't connect this because my arithmetic sequence is only defined when n equals a natural number, not these in-between decimal numbers, any of the irrational numbers in between. Like 2.5, it's not defined at 2.5. So that's why I should just leave it as these dots, which are not connected, if I was visualizing the arithmetic sequence this way. All of that to say, we can see that this is a linear relationship. It's an arithmetic sequence. Always increasing by the same amount. The range would the range be an arithmetic sequence? Well, here's the thing. So the domain is just going to be where n is from the set of all natural numbers. I'll do this kind of weird capital N thing to mean natural numbers, where n is from the set of all natural numbers. The range is only defined at specific points, but it is actually true. It would be an arithmetic sequence. The range would be an arithmetic sequence because the range is my outputs. If you can see, the range is the set of all valid outputs. Well, starting from 28, theoretically, this goes on and on as an arithmetic sequence. It's always increasing by 2. So absolutely, if I were to say what the range is, I have to start at 28. I go up by 2, up by 2. I probably don't want to write that forever, so I can just do dot, dot, dot. And the range is an arithmetic sequence. The range is an arithmetic sequence. Perfect. Yes, the range is an arithmetic sequence. The domain, state the domain of the relationship. Well, yeah, where n is from the set of all natural numbers. Explain why the graph, so part E says, why does the graph not have an intercept? Well, the graph doesn't have an intercept on the vertical axis because n cannot be 0. N equals 0 is not included in the domain. Therefore, there is no output at this value. Therefore, there is no Tn intercept, which would be, in other words, no intercept on the vertical axis. Finally, F, write the equation for the number of bricks in a row, N. Okay, so they're telling us to define different variables, so I'm going to have to deviate from what I had already done, but let's say N equals number of bricks in a row, R equals row number. Well, to be honest, I already kind of have this set up as I already kind of have something like this set up as Tn and N. Tn is my output, the number of bricks, and N is my input, the row number. So why don't I just come up with my general formula for the arithmetic sequence So that'd be Tn equals T1 plus n minus 1 times d. Well, T of n, so that's, I want that as a variable. T1 is 28. N minus 1 times common difference is 2. So let me simplify. So as a general formula, it can look like this using requested variables. What was it? N for number of bricks and R for row number. I know this is a bit confusing because I already used n in a arithmetic sequence way, but let's just say then it would need to be, well, number of bricks equals 2 times the row number plus 26. And the thing I kind of want to draw your attention to is, does that not remind you of mx plus b? So it's like a linear function, similar to a linear function. But we need to be clear that its domain only includes natural numbers. Okay.